Carbon bonding and polymers. So when we look at carbon, we know it has an atomic number of 6 and has 4 valence electrons. So what it likes to do is it wants to get to 8, follow the octet rule like every other element. And a lot of times carbon will form bonds with itself. There are three pure forms of carbon we're going to talk about right here, and actually there's a fourth I'm going to mention. Graphite, which we find in pencils. Diamond, the hardest substance on Earth. Fullerenes are these kind of spherical, these are buckyballs here in the picture. And there's actually one called graphene now, which is a single layer of carbon atoms that's used now in a lot of new processes are trying to make it available. It has high tensile strength and high conductivity. But carbon actually wants to have 4 bonds. A lot of times it'll form 4 individual single bonds. If you look on the bottom, a lot of times it's just hydrogen or other carbons. When it's carbons and hydrogens, we call those hydrocarbons. And there's millions of different compounds that are formed of carbon, hydrogen, and some of them even throw oxygen in. We have carbohydrates that have oxygen in there, sugars and so forth. And so it can go through many different types of bonding. You can do 4 single bonds, a double bond, and 2 single bonds, 2 double bonds, a triple bond, and a single bond. Like the images here show. Got some double bonds, triple bonds. And when we have double or triple bonds, we consider that hydrocarbon or that carbohydrate unsaturated. That means that it actually has space where we can stick more hydrogens on it or waters and things like that. So we say it's unsaturated. And if it has all single bonds, like in the previous page, in the bottom right there, those are all single bonds, that's ethane. That would be a saturated hydrocarbon or saturated carbohydrate. And that means it doesn't have any space to stick anything else on there. We hear these terms a lot in food and fats, saturated, unsaturated, and it just has to do with degree of hydrogenation. And you'll actually hear the dehydrogenated corn oil and things like that. They're unsaturating them. So polymers. Comes from the root poly is many, and mer means part. And polymers are these combinations of small parts called monomers. And they make these very long chains. And some of them are found in nature. We call those natural polymers. And other ones that scientists make or man makes are called synthetics. So just think of hair. We got plenty of us with natural hair, and then there's people that need to go buy some synthetic hair from the store. So when we think about polymers, there are many different natural polymers: starches, cellulose, nucleic acids, which is DNA and RNA, and proteins, all things you'll talk about in biology. And then we have synthetic polymers, and there are countless synthetic polymers. HDP, LDP are like plastics. We have Kevlar, which are bulletproof vests, rubber, epoxy, Teflon, which are coatings, nonstick coatings, polyester and nylon, different types of materials we use in our clothes. PET is what they currently use in most plastic bottles. And when we think about them, we're going to talk about linear, branched, and cross-linked. So you'll discuss those in class. There's different arrangements of polymers. And the reason we do that is we can arrange them differently, and they'll give different properties. So we can make plastics that are made specifically to be resistant to cracking, or we can make rubbers that are very form-fitting, or like memory foam. So the idea is we can make the characteristics of the materials based on how we arrange the atoms. So if we look at these stress strain characteristics, we can measure tensile strength, abrasion resistance, or puncture resistance. And these are standard tests that they do in the industry. So in plastics or even cloth industries, I saw a web video one time of them testing the tensile strength of some fabric. So these are done in industry. And each of them is kind of described there. I'm not going to get into it. LDP, low density. So again, it's low density. It's not very heavy. So it's a lighter plastic. It generally has branching in the arrangement of the molecules. HDP usually has little branching. It's straight chains, linear chains that will stack nice and flat. And they generally have high tensile strength. That means you can pull them quite a bit before they break. It takes a lot of strain, a lot of force to break them. When we talk about recycling, there are different numbers for different types of recycling materials. Like PET, number 1, like I say, is most plastic bottles. Now we have HDP and LDP in there. Polypropylene, polystyrene are in there as well. And then there's polyvinyls, which I think is 3. and others are 7. Just numbers we see on bottles and plastics that we know how to recycle them. It used to be tough. You had to make sure you separated all your recyclables into the right numbers. Now we have single stream recycling, so they do it at the factories or the recycling plants. Fossil fuels, again, are carbon containing compounds. They have these hydrocarbons, the carbohydrates, and other things in there, other types of alkanes. And these are remains of plants and animals. So coal, natural gas, and oil, petroleum, are all found under the ground, and they're, after millions of years, plant and animal remains have become these fuels. And we use them primarily to burn in our cars, at home for oil, at electric plants. And they undergo this reaction, combustion. It's very important to know about combustion. It's a reaction with oxygen, so you need fuel, oxygen, and heat. You get this reaction, and the products of it are carbon dioxide, water, and energy. And again, we'll talk about carbon dioxide as being a greenhouse gas causing or contributing to global warming. And that's it for Unit